Hello everyone, welcome to Module 2 of CS365 Optimization Technique. Optimization is the act of achieving the best possible result under given circumstance. In design, construction, maintenance, engineers have to take decisions. The goal of such decisions is either to minimize effort or maximize benefits. There is no single method available for solving all optimization problems efficiently. Hence, a number of methods have been developed. Optimum seeking methods are also known as mathematical programming techniques, which are a branch of operation research. A mathematical optimization model consists of four key objects. Firstly, data like cost or demand or capacity, etc. Secondly, any system is described by a set of quantities viewed as variables. All quantities that can be treated as variables are called design variables or decision variables. Thirdly, in practice design variables cannot be selected arbitrarily but have to satisfy certain requirements. These restrictions are called design constraint or just constraints. It may represent limitation on the performance or behavior of the system. Finally, the classical design procedure aims at finding an acceptable design, that is, a design which satisfies the constraints. In general, there are several acceptable designs, and the purpose of the optimization is to single out the best design. Thus, a criterion has to be selected for comparing designs, which is known as objective function. This figure shows the constraint surface in the two-dimensional space. The boundaries is known as the constraints and the shaded region is known as the feasible region. Here are some important terminology in optimization model. First one is solution, which satisfies every constraint. Non-negative solutions are feasible solution, otherwise it is known as infeasible solution. If in mathematical model there are n constraints and m variables, then n minus m non-zero solution is known as basic solution. If basic solution is also feasible solution, it is known as basic feasible solution. If at least one basic variable is zero, then basic feasible solution becomes degenerate. Otherwise, it is known as non-degenerate solution. The basic feasible solution, which is optimize the objective function, is known as optimal solution. And the solution which is not bounded is known as unbounded solution. An optimization mathematical problem can be stated as follows. Here, x is the decision vector with n variables, and f of x is the objective function of x, while gi of x is inequality constraint, while hj of x is the equality constraint. Here all xi variables are considered to be positive. The following steps summarize the procedure used to formulate and solve mathematical problems. First, analyze the process to identify the variable and specific characteristics to interest and determine the criterion for optimization. Specifically, the objective function is in the term of this variable with coefficient. Secondly, develop a mathematical expression that relates the input-output variables of the process and associated coefficients. This expression includes both equality and inequality constraint. It must use well-known physical principles. From this, identify the independent and dependent variables to get the number of degrees of freedom. If the problem formulation is too large in the scope, break it up into manageable parts or simplify the objective function and the model. Now apply a suitable optimization technique for this problem. Finally, examine the sensitivity of the result to changes in the coefficient in the problem and the assumption. Let us consider an example. A chemical factory produces a chemical from two materials X and Y. X can be purchased for $5 per ton and Y can be purchased for $1 per ton. The manufacturer wants to determine the amount of each raw material required to reduce the cost per ton of product to minimum. Formulate the problem as optimization problem. Here, the objective is to minimize the cost per ton. Hence, it is expressed as the minimize f of xy equal to fx plus y. Since x and y are number of materials, therefore it must be positive value. Let us consider another example here. Given the perimeter of a rectangle as 16 cm, we have to construct a rectangle with maximum area. Since we have to maximize the area, the objective function can be expressed as maximize f of xy equal to xy, where x and y are length and breadth respectively. Here, the constraint is that the perimeter of the rectangle, which should be 16. Hence, it is expressed as 2x plus 2y is equal to 16. Since the length and breadth are positive, therefore the variable must be positive. In discrete optimization techniques, some or all of the variables in the model are required to belong to discrete set. This is in contrast to continuous optimization technique in which variables are allowed to take any values within a range of values. There are two main branches of discrete optimization technique: linear programming and combinatorial optimization techniques. Continuous optimization problems tend to be easier to solve than discrete. However, improvements in algorithm coupled with advancement in the computing technology have dramatically increased the size of complexity of discrete optimization problem that can be solved efficiently. In mathematics, unimodality means possessing a unique mode. More generally, unimodality means there is a single highest or lowest value of some function. Figure A shows an example of unimodal function, while B shows the multimodal functions, since there are more than one modes. In the second figure shows the convex and concave function. A function is said to be concave if every line segment joining two points on its graph does not lie above the graph at any point. Similarly, a function of single variable is convex if every line segment joining two points on its graph does not lie below the graph at any point. To make this definition more useful, we can translate it into algebraic condition. F of lambda x minus 1 minus lambda y is lesser than or equal to lambda into f of x plus 1 minus lambda f of y, then f is said to be convex. F of lambda x plus 1 minus lambda y is greater than lambda f of x plus 1 minus lambda f of y, then f is said to be concave. These concepts are illustrated in this figure. Clearly, you can see that in the convex function, the line segment joining two points on the graph lies above the graph at any point, while in the concave function, no line segment joining two points on the graph lies above the graph at any point. If the function is twice differentiable, then it is concave if and only if its double derivative is negative. Otherwise, it's convex. Here are few examples of unimodality, convex and concave. Sin x is a unimodal function in the domain 0 to 2π. It is also a concave function, but it is not unimodal if we consider the domain 0 to 3π, since there are more than one modes. From here, we can conclude that this property is totally dependent upon not only the property of the function but also the interval. Exponential function is convex function in every domain, but it is not unimodal function. Minus x square is a concave function everywhere. Now, let us consider few examples from management field in which optimization has got important role. Let us begin with investment. An investment is an asset or item acquired with goal of generating in appreciation. In an economic sense, an investment is the purchase of goods that are not consumed today but are used in future to create wealth. In finance, it is a monetary asset purchased with the idea that the asset will provide the income in the future or will later be sold at higher price for a profit. The common form of investment include financial market like stocks, bonds, credits like loans, assets like commodities or artwork, and real estate. Here are few other examples of investment: commodities, cryptocurrencies, real estate, stock, bond, and other options. Investment cost is something that is totally different from investment. It is the amount of money spent for investment. In other words, cost of converting investment opportunity into options underlying asset. The cost of investment includes acquisition charges such as brokerage, fees, and duties. The investment cost usually incurred are commission fees, investment at the time of purchase, annual fee based on value of investment portfolio, and built-in fee, which is a hidden cost which is a part of purchase structure. Investment costs might not seem like a big deal, but they add up, compounding along with the investment returns. In other words, you don't just lose tiny amount of fee you pay, you also lose all growth that money might have had for years into the future. The role of optimization is to optimize the investment return given the constraint, which is investment cost. Consider this example in which $100,000 is invested. If the account earned 6% a year for the next 25 years without any cost or fees, you would end up with $430,000. If you consider 2% investment cost per year, after 25 years, you would have $260,000. This means $170,000 have been spent for investment cost, which is totally a big deal since this is more than earning. Operational costs are the routine cost of running a business. While these vary based upon time of businesses, many basic type of operational cost exist that a business must consider when budgeting. In the figure, B and C shows pie chart of operational cost of two different companies. Operating costs are ongoing expense incurred from the normal day-to-day of running a business that include both direct cost of goods sold and includes everything from rent pay, toll, other overhead cost to raw material and maintenance expenses, etc. Operating cost can be found and analyzed by looking at company's income statement. Operating cost may include operating expenses like bank charges, sales cost, travel expenses, entertainment cost, salary, etc. Operating cost will also include the cost of goods sold, which are the expenses directly tied to the production of goods and services. Generally speaking, a company's management will seek to maximize profit for company. Profits can be increased both by increasing revenue and by decreasing operating cost. Because cutting costs generally seems like an easier and more accessible way of increasing profit, manager will often be quick to choose this method. However, trimming operating cost too much can reduce company's productivity and thus its profit as well. While reducing any particular operating cost, it can also hurt the company's earnings in the long term. For example, if a company cuts its advertising cost, its short-term profit will likely improve. However, by reducing its advertisement, the company might also reduce its capacity to generate new business and earnings in the future could suffer. Ideally, companies look to keep operating costs as low as possible while still maintaining the ability to increase sales. Every process has a constraint. Focusing improvement efforts on that constraint is the fastest and most effective path to improve profitability. The theory of constraint is a methodology for identifying the most important limiting factor that stands in the way of achieving a goal and then systematically improving that constraint until it is no longer the limiting factor. Constraints can be external or internal. External constraints are when the system can produce more than what the market demands. In such case, organization could create demand for the product in the market. Internal constraint is when the system delivers less than the market demands. So, the organization should focus on disconcerting and removing or reducing the impact of its own throughput. There are various types of constraints that impact the rate throughput, such as firstly, equipment constraint like availability of the equipment, working hours of machinery, efficiency and maintenance requirement, etc. Secondly, availability of skilled employee or labor and high labor cost. Finally, the policies and the processes of set by the organization may sometimes hinder or act against throughput maximization. External constraint is considered to be difficult to control since it is totally depending upon demands, which is outside the business. Internal and external constraint go hand in hand. There is a fine dividing line between them. For example, if you are applying for a loan for a business, the amount how much to be borrowed is the internal constraint while the interest rates are external constraints. In attempt to maximize the profit, we must consider both short and long-term implication of decisions made within the firm and the various external constraints that could limit the firm's ability to achieve its goal. These constraints can be organized into three categories. Firstly, the first external constraint, resource scarcity, refers to the limited availability of essential inputs, which includes skilled laborers, key raw materials, warehouse space, etc. Moreover, managers often face constraints on plant capacity that are exacerbated by limited investment funds available for expansion or modernization. Secondly, contractual obligation also constrain the managerial decision. Labor constraints, labor contract may affect managers' flexibility in workers' scheduling. It may also restrict the number of workers employed at any time. Finally, laws and regulations have to be considered. Legal restrictions like minimum wage, health and safety standards, fuel efficiency requirements, anti-pollution regulations, etc. can limit managerial flexibility. Hence, we have come to the end of Module 2.